Here we're asked to evaluate the limit as x approaches 3 of the square root of x plus 1 minus 2 divided by x minus 3. If we try direct substitution, we see that when we plug in a 3 everywhere there's an x, we get the square root of 3 plus 1, which is the square root of 4, or 2, minus 2, which is 0. And in the denominator, 3 minus 3 also gives us 0. And we have learned that this 0 over 0 is called indeterminate form. And when we get indeterminate form, that means we need to find another method of evaluating the limit. Looking at this function, we see that the numerator contains a radical expression. So that's a hint to us that we might try the rationalizing technique in order to evaluate this limit. So what we're going to do is to multiply both numerator and denominator by the conjugate of this numerator. Because we're multiplying by a fraction whose numerator and denominator are the same, that's the same thing as multiplying by 1. And we know that we can multiply any expression by 1 without changing the value of that particular expression. So now, to multiply, we're finding the limit as x approaches 3 of the first term times the first term simply gives us x plus 1. The outside terms give us plus 2 square roots of x plus 1. The inside terms gives us minus 2 square roots of x plus 1. That goes to 0. And the last terms, negative 2 times positive 2, give us a negative 4. In the denominator, we're simply going to leave everything written in factored form. We don't want to multiply it out. We just want to leave it in factored form, and that's going to be the case that we're always going to use with our denominators. Now let's simplify. We have the limit as x approaches 3. The numerator simplifies to x minus 3. And in the denominator, we still have that factored unit, x minus 3 times the square root of x plus 1 plus 2. Examining the fraction now, we see that in the numerator we have a factor that's common to a factor in the denominator. So those factors divide out to give us 1. And then we simplify again and write the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. Now, try direct substitution again. Plugging in a 3 for the x, we get the square root of 3 plus 1, which is the square root of 4, which is 2, plus 2, which gives us 1/4. And so now we've evaluated the limit using the rationalizing technique.